So we have prepared a few slides to introduce some key concepts and setup of LifeTime to everybody. And so this is LifeTime, and we'll now progress to the next slide somehow. Okay. This is a slide where you go with us for a moment on a journey through life. So imagine cells which normally would develop or differentiate and form a healthy human. But then maybe something happens, it could be a mutation, and there is a deviation in this path towards disease. And I think it is clear that in many cases when the symptoms come in and the suffering starts, then this path has been already there for a while. It's also clear the longer you wait, the more difficult it gets to bring these cells or patients back to health. So it's not only more difficult, it is also much more invasive the longer you wait, and also the burden on the society increases. And so what we think in LifeTime is that by combining several key methods and applying them to a disease, we can push the diagnosis to much earlier points, and we will be in the position to intercept much earlier and think that then it should be easier to push the cells back to health. It is key to understand, we think, the mechanisms that propel cells from time point to time point. So if you want to explain the differential in molecular states from one time point to the next in health or in disease, we'll need to study the molecular mechanisms within the cell, and we think that we are now getting the data to exactly do this for differential, again, time points. But the knowledge about how cells really make decisions to progress during disease or during health becomes super important at this point of deviation. And one obvious corollary is that if we understand this deviation point better, we are immediately in a position to also intercept with much more knowledge about which targets to hit. So how do we want to achieve this? We want to combine three technologies. One is single-cell multi-omics, which is revolutionizing a lot of basic research right now, together with imaging, of course. Then we want to understand mechanisms. That is very important to us, as I explained. And so we'll work in classic disease models, but as a new emerging technology, we are very excited about organoids, which can be derived now from many organs in a patient a specific way. We can do, for example, using CRISPR-Cas experiments to test hypotheses that we generate with, for example, applying machine learning or artificial intelligence to the molecular data that we are generating when observing how cells march through life or during disease progressions. So I think these are the main ideas. So it boils down that we want to track, to understand molecular mechanisms and to target human cells during disease. Now, this is all at this point an exercise, a somewhat theoretical exercise, and now Geneviève will explain how actually this very complex task can be, we think, tackled.
Okay, so you have the general concept, and I think a very important thing, and I just want to say it as well, that to do this here, when we place the cell at the central place, with Virchow being the person that had defined the cell biology, it was really important. So how do we do that? I think it's really a matter of people and of coherence, because all the different pillars that have been listed by Nikolaus have to work really together. And so you can see here that we have about 60 research institutes in 17 countries in Europe that have really put effort together to build up what we are now discussing. So I would like to take this opportunity to thank all the people that have really brought in their interest, their ideas to get there. And this is also important to stress, and that was mentioned earlier. We have, as Otmar mentioned, from the very beginning made the wish, which turns to come true, to also engage with industry of different area. And you can see here over 80 companies have signed up to show their interest, and we really want to build on that as well. And this is in all sorts of area, not only pharma, but also medical diagnostic, biotech, imaging technology, IT and data science, and other single cell technologies, of course. So it will be very important for us to foster efforts around the question we want to address together, and to make progress towards applications as well. And so here you have a list of the people that have contributed beyond the partners. Also, they are also associates, and so this is also important. So you have the partner, of course, we are on the stage, but there are many people who are in the room, and I hope that you will be able to talk to them from many countries that are listed here. It's hard for me to go through all in details, and I apologize if I don't list them for all of that. So I also want to say that we had the pleasure when we were here for the opening of the BMSB Institute, which is emblematic of a gathering of people interested by this topic, that Angela Merkel was extremely excited by the project. So here, in addition, we also need to have people that can provide us generous advice, and this is all over the world, because what we are doing in Europe is really embedded in a larger scale. And so you can see here, perhaps it's a bit difficult, but prominent people from all over the world have accepted to accompany us in this journey and offer their generous contribution to build up on what we are doing. And so we had, just as yesterday, a very interesting discussion with the group of this scientific advisory board, and their excitement even bring further excitement to us as of today. So that is really, really encouraging. So I'm sure that you can, I hope you can recognize some of them on this picture, and it's going to be really nice to work with them. So maybe in concrete terms, what we are meant to do, because this is also why you're here, you would like to know in concrete terms how you can contribute and help to move forward. So basically we have now, after these 2 years of preparation, 1 year to consolidate this initiative. And so according to a roadmap that we have to deliver to the European Commission. And so as part of what we envisage, there are different aspects, but perhaps one that I'd like to stress is the spirit, which is really an open spirit. And here, this is also why having a lot of people participating with your ideas today and tomorrow is key. We want to have approaches with open calls that will be competitive and peer-reviewed. We also have some call for, this can be for individual to promote new upcoming talented people, but also call for smaller group that could work or tackle some particular question that we will have to select in terms of the order in time, and also to have places where people can gather that would function as nodes in terms of the way they can function and bring technology together in different places, and we will have call for that as well. And so a key question that has really occupied us a lot during many of our discussion is what will be the disease on which we will put effort. And in fact, we decided to set up this system that we called Launchpad, which is really a system that should enable us to decide which choice we can make based on an informed thinking, taking the input of doctors, of researchers, and in all the three pillars that we mentioned to tackle the question on aspects that are amenable to the questioning we want to develop. So that's really important. So you want to add one thing? Sure.
Yeah. Just to say that this launchpad is, Geneviève said it, but I want to expand this, is a really complex procedure that requires experts from very different, let's say, stakeholder groups to come together. So you mentioned the doctors, the researchers, then there are, of course, also the patients.
Definitely.
Then there's the industry, there are the policy makers also. So it's a very complex discussion, but we want to be very transparent about this. So that this, if you will, matrix, so diseases then analyzed in all these different aspects will be one transparent product that we will constantly develop and improve.
So that is really underlining the importance of all the stakeholders that should really contribute. So here...
sorry, I need to... the cell centers are also, I think,
yes.
deserve a few words.
You want to...
So, of course, open calls are extremely important for individuals, but in some... for some diseases or methods development and application, you also need a critical mass. Without this, this will not really deliver the impact that I think we can have. And so we want to make open calls so that the countries, member states, and institutions can compete for some aspects of LifeTime to be developed in a more focused way. We call these could be virtual consortia, these could be physical places, but we call these cell centers, and we think they're important not only for critical mass aspects, but also to connect to the public, to connect to the industry, to maybe also connect to venture capital, to start to support us in really making, for some scientists, to make products or spin-off companies and so on.
And for training as well, to some extent. I think they will be really critical nodes. So,
it's come.
So now, just to introduce the people that have and are around here that you will see that are key in the organization and coordination. So of course you see us now on the stage, but there's also Marie Vidal, who is very involved in the interaction with the industry, but many other things as well. Christian Pop, who is a project officer. We don't have a picture of Valentine, who is our communication officer, but he's just here on the left at the first row, so you cannot miss him. And Dr. Nikolaus, who is an EU officer, who is also standing there and controlling the time for the moment, and Maiku Cha, who is the stakeholder officer, and she's also around. So don't hesitate to talk to them if you need. So one more thing I'd like to do, of course, is to wish you to enjoy the meeting, but I also want to say that we would like to make sure that we can communicate at the best what our goals are and how we can move forward. And as part of that, we would like to put together a paper that we intend to publish soon so that it can be really shared with the community. I know that there are a number of editors in this room. I think that this will be one of the paper that we can publish, but there are also, as part of the work that is ongoing, possibilities on different items to have additional paper. We are supposed to deliver some of them to the EU, but they can definitely be very useful also to share with the community and be published. You want to add something to this?
Yes. So many people ask about the relationship with the human cell atlas.
We can.
So we have discussed with Aviv and Sarah and other HCA members, and it is clear to us that the relationship can be depicted maybe best as a Venn diagram. So there is a clear intersection, which is people. Lots of HCA people are active in LifeTime and the other way around. So there's a lot of shared know-how, ideas. We will share platforms, technologies, standards, and so on. But then there's also a part which is really in LifeTime and not that particular to HCA. And this is the focus on diseases and their progression and mechanisms. So we really want to understand, as I said, the differential, as I like to call it, in time. And so for this, we really want to tackle molecular mechanisms. And so for this, we need, as explained, disease models such as organoids and others. And we need to really interrogate the data which are generated to understand cause and consequence. So this is something that we will also explain in the white paper, but the Human Cell Atlas supports LifeTime, and we support HCA, so there's really friendship and a lot of excitement and mutual benefits.
I would just like to add on this particular note that it is really important that what we are trying to do is embedded in an informed and synergistic manner with other actions that can take place worldwide. So HCA is an obvious one you can think of, but I'd like to stress that 4D nucleome as well, that has started in the US, is another one that has also very strong ramification and interaction with us. We are in contact with people that are engaged into 4D nucleome, but there are also a series of other actions at an international level, and we don't have the list here, but many of the people at this level are also in Japan, US, Canada, Quebec, and you could name them, have also been in touch with us so that we can really build on what is already existed and synergize and bring up the new angle together.
Finally, from personally, I have to say that I'm quite overwhelmed by the absolutely outstanding scientists who have come together here. And just in this room, they're really some of the top brains that Europe has to offer. And I think this is an absolutely amazing opportunity for us to really change the next 10 years and fill them with a lot of progress in all regards. And so I'm thankful for this. I think we all should be thankful for that this somehow has arisen as an opportunity. And so, Geneviève, maybe we can just, us two collectively, wish you a lot of fun and good discussions and friendship.
And of course, great brain, no pressure. We expect a lot from you. So for these next 2 days, thank you very much for your time, interest, and contribution. Enjoy.